We're going to be talking about the least common multiple. So the first thing we need to do is define what is a multiple. So a multiple is number created by multiplying the original number by any natural number. So just as a reminder, natural numbers are 1, 2, 3, 4, so on and so forth. Multiples will always be greater than or equal to the original number. So an example of a multiple might be 2 times 3, which is 6. Okay, 6 is a multiple of both 2 and 3. Okay, so we want to find the first 6 multiples of each number and list them in ascending order. So the way we do this is simply take that value and multiply it by the first 6 natural numbers, 1, 2, 3, 4, 5, and 6. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4, 24, 6 times 5, 30, 6 times 6, 36. Those are the first 6 multiples of 6. So pause the video, try the same thing with 20 and 13 on your own, and then come back and check your answers. Okay, so we should have gotten 20, 40, 60, 80, 20, or excuse me, 100 and 120. And then for 13, we should have gotten 13, 26, 39, 52, 56, and 78. So we're going to be using these finding multiples in order to find the least common multiple of 2 or more numbers. All right, and we're going to look again at 2 different ways of doing this, just like we did with the greatest common factor. Okay, so the first way to do this is to list out the first 5 or 10 multiples of each of the numbers. And depending on what happens with the numbers, you might need to list out more than that, which makes this kind of an inefficient process. So we're going to do an example of what happens with the numbers 8 and 10 when we're looking at listing out these multiples, okay? So when we do this, we get the multiples of 8, 16, 24, 32, 48, 40, and 48 for 8, and then 10, 20, 30, 40, 50. And these are the multiples, and we're looking for the least common. Okay? So they do not both have 8 in common. The other one doesn't have 16, 24, 32. But when I look at 40, they both have that in common. 10, 20, 30, they don't have those in common. So 40 is the smallest multiple that both of these numbers has. Okay. So we're simply going to identify only multiples that they have in common and then find the least of those. Okay, and we get an LCM of 40. Now the other way we can do this is very similar to what we did with GCF, which is use our prime factorization. So we're going to find our prime factorization, all right? 8 is equal to 2 times 2 times 2. So again, you could do a factor tree or you could divide out. And 20 is equal to 2 times 2 times 5. Okay, so we've prime factorized each number. Now we want to identify the most each factor occurs in either number. Because remember, a multiple needs to be larger than or equal to our starting value. So we want to pick the most possible of each factor, but we only can pick a factor from one number. Okay, so if I'm looking at the 2's, the most 2's that occur are with the 8, and there are 3 of them. All right, so for my LCM, I'm going to pull out those 3 2's. Now the next, I have a 5, and the most 5's that occur is in the factors of the 20, and there's 1 of them. We're going to multiply those together. We're hoping we get 40, and when we multiply them together, we do in fact get 40. So let's try this out on a few more examples. We're going to look at these two examples down here. So again, we're first going to find the prime factorization of these numbers. So we're going to look at 14 and 24. We're going to find those prime factorizations. Once you find your prime factorizations, you want to go through the prime numbers and identify the most of each number. So if I'm looking at 2's, the most 2's occur in the factors of the 24, and there's 3 of them. The next prime number is 3. The most 3's occur in the factors of the 24, and there's 1, 3. And then the next number I have in here is 7's. The most 7's occur in the factors of 14 with the 7. You want to multiply those all together to find your LCM of 56. So let's try this with 3 numbers. First, again, prime factorization. Once you have your prime factorization, identify the most of each factor. So it's the least common multiple, but you want the most factors since multiples are larger or equal to their original numbers. So 2's, the most 2's are up here. 5, they're the same for the prime factors of 25 and 50, so it doesn't really matter which one we pick, but we can only pick, remember, a grouping from one prime factorization. We can't take both sets. So our least common multiple will be 2 times 2 times 2 times 5, which is 200.